The last decades have witnessed an impressive evolution of data consumption, with the proliferation of smartphones and mobile network users. Actually, the number of subscribers has increased rapidly, and new use cases requiring robust telecommunication systems have been identified. All those factors have led to an impressive evolution of cellular networks, from voice-centric services such as 1G and 2G to data services with 3G and mobile broadband communications offered by the 4th generation LTE, which stands for long-term evolution. 5G, which is the 5th generation of cellular networks in turn, promises to be a game changer, offering faster data speeds, lower latency, and greater network capacity than any of its predecessors. 5G is deployed based on 4G LTE features, which has been the standard for mobile networks for the past decade. However, where 4G was focused primarily on delivering faster data speeds to consumers, 5G takes things to a whole new level. With the ability to transmit data much faster, 5G has the potential to transform not just the way we use our mobile devices, but also the way we live and work. But before we go any further, let's take a look at cellular networks' evolution from 2G to 5G. Mobile communication has come a long way since the introduction of the first cellular networks in the 1980s. With each evolution, cellular networks have become faster, more reliable, and more efficient. The first generation of cellular networks, known as 1G, provided analog voice communication. But the first breakthrough in cellular communications was the introduction of GSM or 2G, which was the first digital cellular technology. 2G networks offered a number of significant improvements over their analog predecessors, including increased call quality, better security, and the ability to send text messages. However, data speeds were limited, and internet access was not yet possible. With the introduction of 3G networks, mobile internet access became a reality. 3G networks were the first to support higher data rates, allowing for faster downloads and streaming of multimedia content. 3G also enabled video calling, mobile gaming, and other data-intensive applications. The rise of mobile internet began its journey with the proliferation of advanced smartphones and the massive deployment of 4G networks. This technology marked a significant leap forward in mobile data speeds and capacity, since 4G technology has allowed much faster downloads and uploads, making it possible to stream high-quality video and use other data-intensive applications with ease. Besides, 4G networks were more efficient and reliable than previous generations, resulting in better coverage and fewer dropped calls. And here comes the big leap in the telecommunications world, which is the standardization of 5G cellular networks. 5G offers data speeds up to 100 times faster than 4G, and it has the capacity to support a massive number of devices and applications. 5G also offers ultra-low latency, making it possible to support new applications like self-driving cars and remote surgery. So, in this video, I will give you an overview of 5G cellular networks and the main use cases requiring advanced communication features that 5G provides. So make sure to subscribe and watch the video till the end. Hello and welcome to this new video on 5G cellular networks. In today's video, we will talk about 5G service classes as defined by the International Telecommunication Union and the requirements of each class of service in order to understand why we consider 5G a technological breakthrough in cellular communications. But before, what are the major differences between 5G and its predecessor 4G? The quick answer is that 5G doesn't focus only on offering high-speed data rates and mobile broadband communications as 4G did. The main reason behind the standardization of 5G, in addition of course to mobile broadband use cases, is vertical business, especially industrial use cases. In fact, one of the key benefits of 5G for industry and vertical business is its ability to enhance productivity and efficiency. With ultra-low latency and high-speed data transmission, 5G enables real-time communication, which allows businesses to respond more quickly to changing market conditions, customer demands, and supply chain disruption. For example, 5G powered robots and drones can help businesses automate tasks and reduce operational costs while also increasing accuracy and speed. Therefore, the International Telecommunication Union has classified the main use cases that 5G will cover into three major service classes, with specific technical requirements for each one. On the other hand, the third generation partnership projects, the 3GPP, starts the process of standardization by defining the different technologies that respond to the EMT 2020 requirements. So, what are the three classes of services defined by the International Telecommunications Union for the 5G standard? The first one is EMBB, Enhanced Mobile Broadband. This class of service provides higher data rates, lower latency and greater capacity than previous cellular generations, making it well suited for high bandwidth applications like video streaming, online gaming, and immersive media. With EMBB, users can experience download speeds of up to 20 gigabits per second and upload speeds of up to 10 gigabits per second, which is several times faster than 4G LTE. Of course, this is the theoretical throughput in an ideal setup. In the real conditions, the data rate is up to 1 gigabit per second with deployments that we have today in the mid-band frequencies. EMBB also enables a range of new services such as virtual and augmented reality, which require high bandwidth, low latency, and high reliability. In addition to that, with 5G, businesses can develop new applications and services that rely on high-speed data transfer and low latency connectivity, such as smart factories and Industry 4.0 use cases. The second class of service is Massive Machine Type Communication, MMTC. This class provides support for large-scale, low-power and low-cost Internet of Things devices, such as sensors, wearables, and smart meters. With MMTC, businesses can deploy a large number of IoT devices and sensors, up to 1 million IoT devices by kilometer square, that can communicate with each other and with the network in a reliable and efficient manner. MMTC provides high capacity, low power consumption, and low device cost, which makes it well suited for applications that require large-scale deployment of low-power IoT devices. With MMTC, businesses can develop new applications and services that rely on massive data collection and analysis, such as smart cities, environmental monitoring, and precision agriculture. The third class is URLLC, which stands for Ultra Reliable and Low Latency Communication. This class provides ultra-low latency, high reliability, and high availability, which is convenient for mission-critical applications that require real-time responsiveness, such as industrial automation, public safety, and healthcare. With this class, users can experience latency as low as 1 millisecond, which is absolutely necessary for applications that require real-time control and response, such as autonomous vehicles and drones. In order to achieve these requirements, 5G has introduced several technologies for radio access network and core network, such as network slicing, 3D beamforming, deployments in different frequency bands, scalable orthogonal frequency division, multiple access, edge computing, and virtualization. I will of course cover these technologies in the upcoming videos. And that's it for today's video. I hope that you now have a better understanding of the importance of 5G in today's and tomorrow's world. Make sure to subscribe to my channel and like the video. Farewell.